Hi class, let's take a look at problem 8. So the function that we're given here is a sine function. And what they want us to do is to estimate the slope of the tangent line for this function at technically x is equal to pi over 4. So the first step that we're going to do is technically evaluate in this case, the average rate of change. So let me start here. I'll just say that for f of x is equal to the sine of x, we're going to be obtaining, and remember that this will be the best option in order to evaluate f of x plus h minus f of x divided by h. I'm just going to use an x value. So in this case, the expression f of x plus h minus the values of f of x divided by h is equal to a sine of x plus h minus technically a sine of x over the values of h. Now I'm going to use the identity that sine of x plus h is equal to a sine of x cosine of h plus the values of cosine of x sine of h. So what we're going to be doing here is evaluating the actual sine of x portion with the actual identity. So this is going to be equivalent to a sine of x cosine of h plus the values of cosine of x sine of h minus the values of sine of x, and all of this is under the values of h. We're assuming, of course, that h cannot equal to 0 since we are looking at some sort of a distance. Now in the next step, what I'm going to do is I'm going to actually rewrite the expression. So in this case, let me rewrite it here. This is still f of x plus h minus f of x divided by h, and I'm going to rewrite the expression. I'm going to pair these values up. So I'm looking at, this is the sine of x cosine of h minus the values of sine of x plus the cosine of x sine of h, and all over this is over h. And then from these two, I'm going to actually factor the signs. So we're looking at a sine of x times a cosine of h minus 1, and then technically it's all over the values of h, plus a cosine of x times a sine of h over the values of h. And then what I'm going to do is just rewrite it so that we can use the identities that are given in the problem as hints. So you have that the cosine of h minus 1 divided by h is approaching 0, and then the values of sine of h over h is approaching the values of 1. So at this point, let me rewrite it, and this is going to be the sine of x times the cosine of h minus 1 divided by h plus the cosine of x times the sine of h over h. And then we technically have that in this case, let me just rewrite it with the limit. So the limit as h approaches 0 of cosine of h minus 1 over the values of h, this is equal to 0. And the limit as h approaches 0 of sine of h over h, this is equal to 1. So we're going to use those two, and then you're looking at the sine of x will technically times 0 plus the cosine of x times the values of 1. And then this expression just gives us the cosine of x. Now, this is going to be our rate of change. So in this case, for this particular problem, let me just write it out as f of x plus h minus f of x divided by h. This is equal to a cosine of x. Now, the next portion is the slope. So technically, the slope of the tangent line at x is equal to, and the problem happens to be, they're looking at x is equal to pi over 4. So I'll just say that m tangent of pi over 4, it's going to be equal to the cosine of pi over 4. And this is going to give us the square root of 2 over 2. So in this case, this is going to give us the square root of 2 over 2. It's one of the identities. And then I'll just rewrite it as m tangent at pi over 4. This is equal to the square root of 2 over 2. This is going to be our final answer. For this problem, they just want us to estimate. In this case, we actually found the value at the pi over 4. And I also provided the equation, but they don't want the equation. Let me just double check. They just want the slope. So for the slope at that coordinate point, you're going to have the square root of 2 over 2. Let me show you the actual equation of the tangent line. Now, what the value that we found in terms of m, that is technically the slope of this line. And then what I provided here is a portion of the sine function, just half of a period. And then that is the actual coordinate point, pi over 4, comma, sine of pi over 4, which is the square root of 2 over 2 as well. And it just happens that the slope of this line at that point happens to also be the values of the square root of 2 over 2. So that's what we found. That's going to be the actual slope of the tangent line at that point. Another part that I'm using here is I'm already evaluating the limits. The identity just says, well, to use the fact, but this is the actual notation for the limit. That's actually it for this problem.